So as I mentioned in our last site visit, we worked with RDH to do some testing for us to ensure we didn't select an insulation strategy that would end up damaging the walls. In order to understand the specific stone type that these walls are actually made of, they performed some material property testing. What that involved was selecting 5 different stones, which they ended up categorizing into 4 different types, which included granite, limestone, sandstone, and gneiss. They then tested them to determine what's called the critical degree of saturation, which identifies how susceptible each stone type is to freeze-thaw damage. This material testing provided the necessary data to run the hydrothermal modeling, which is a software program used to model the long-term effects of heat and moisture within the wall assembly, and it is very specific to the materials being used, the conditions inside the house, the geographic location of the building, and like any modeling, the quality of the output is determined by the quality of the inputs, which is why we went through the exercise and the effort of testing the properties of the stone. For the hydrothermal modeling, we looked at a number of different scenarios and potential assembly types, including closed cell spray foam only, mineral wool insulation, and a hybrid of spray foam insulation and fiberglass bats. Ultimately, we determined that all 3 insulation strategies were actually safe. We weren't at risk of freeze thaw, and we weren't at risk of mold, which was great because it actually provided us with multiple options. We ultimately decided to use a hybrid strategy or a flash and bat for a few reasons. Spray foam is great for sealing evenly across inconsistencies within the stone, which would be really challenging with bats or even a rigid or semi-rigid insulation. It also has a really high R value per inch, so we don't have to build our walls out as far as we would have with mineral wool or fiberglass to accomplish the R30 target. It also simplifies a lot for us by accomplishing a continuous insulation layer and a vapor and air control layers all with one application. This would take significantly more work to accomplish with membranes and tapes and ultimately add more cost. Since we were able to accomplish all of that with the first 3 inches, or phase 1, as you can see installed here, we opted to fill the stud walls with a more cost-effective R14 fiberglass, which will be installed once these walls are all framed.